Okay, so here are a few extra examples from section 1.4. So in this one, we're finding the domain of the composite function, and we're given the two functions f and g. So f of x equals 1 over x, and g of x equals square root of x minus 1. And we want to find the domain of f of g of x. Well, so what do we know here? Well, here we know x cannot equal 0, and here we know that x has to be greater than or equal to 1. Okay, so that's because, we set what's underneath the radical greater than or equal to 0, solve. So we took the 1 over, and we got that value, and here we know we can't divide by 0. So those are the two individual domains of what we'd have. And then if we wanted to write an interval notation, we could do that. But we want to find f of g of x. So we're going to plug in g of x into f of x. So f of g of x is equal to 1 over the square root of x minus 1. Okay, so now with this one, what do we have? Well, we have to think about how this works. Here we know that this has to be greater than 0. So x minus 1 has to be greater than 0. Now it's not going to be greater than or equal to at this point, because if we have it equal to 0, then we're going to divide by 0, and we can't do that. So it has to be strictly greater than 0. And so that means x has to be greater than 1. Well, what does that give us for interval notation? Because it's usually what it wants. Well, it's going to be from 1 to positive infinity. Okay, so that's going to be what our domain is for this equation, or for this f of g of x. All right, what about the next one? Well, here again, we know just by itself, f of x, the x cannot equal 0. And here, this is going to be basically from negative infinity to positive infinity. Any number you plug in here will work. Well, now this time we want to find f of g of x and g of f of x. So f of g of x is equal to, well, now we're plugging this into here, so that's going to be 1 over x minus 3. And so what do we have here? Well, basically, we set x minus 3 equal to 0, and x equals 3, and so that's what it cannot equal. Okay. And so what do we have for the domain? And then our domain is any number but that. So we can go from negative infinity up to 3, but not including it, union 3 all the way up to positive infinity. So that would be our f of g of x. Now what about going the other direction, doing g of f of x? Well, now we're going to plug in the f of x into here, so that's going to give us 1 over x minus 3. Well, here, the only restriction we have is x cannot equal 0, because if it equals 0, then we're dividing by 0. And so here our domain is going to be from negative infinity to 0, union 0 to positive infinity. Okay. And so that's going to be how we do that one. So this is a pretty simple one where you just have the 1 over x or the 1 over x minus 3, where we have to find our domains. And so that's what it is. So that's your two domains for the f of g of x and g of f of x. Now on this one, we want to find g of f of x. Okay, so how do we do that? Well, we have, where's my pen here, g of f of x. And so we're taking f of x, plugging it into g of x, so that's going to be minus 3 over square root of 2 minus 4x. All right, so how are we going to do this? Well, this time we know that this has to be greater than 0 normally, but also has to be greater than 0 to be part of the fraction. So we're going to take 2 minus 4x greater than 0, and we're just going to solve for x. So I'm going to add 4x to both sides. That way I don't have to remember to change my sign. And so 2 is greater than 4x. Divided by 4, and so we have 1/2 is greater than x, or if you read it how it would be, x is less, or not less, yeah, I say less than, and I write greater than here, is less than 1/2. Okay, so basically anything less than 1/2 will work for this equation, and anything greater than the 1/2 or equal to 1/2 will not work. And so our domain is basically from negative infinity up to that 1/2. All right. So the next one we need to find f and g of x. So the function h of x equals f of g of x. Okay, so again, we're decomposing these functions is what we're doing. So we need to find a g of x and f of x. And again, what I want to do is I want to find the one that's easiest to do. And what that means is I look and see what is plugged in here. Well, I'm going to say, well, g of x is x squared plus 7. Well, what do I use here if that means, what do I have for f of x? Well, that's just the square, or absolute value of x, because if I plug this in to here, I've got this value here, okay? And so that would be my f of x, and that would be my g of x. All right, so 2, what would I do here? Well, this one is a little, could be tricky depending on how you want to look at it. Again, I'm going to use the most obvious one. And the most obvious one is basically if I say everything in here is just x, that would be x to the 4th. And that would be my f of x. Well, then what does that mean I had to plug into it? Well, I had to plug in this fraction, the 8 minus x to the 3rd, or 8 plus x to the 3rd over 8 minus x to the 3rd. And that whole thing would be my g of x. So I'm going to plug that in here, and I would get this out, okay? What about the next one here? Well, here I have 1 over 3x squared minus 4 to the negative 3. Well, again, I'm going to do the most obvious thing possible. And I'm going to say, well, let's get rid of everything in here and replace that with x. If I do that, that's 1 over x to the negative 3. Okay, well, what did I plug in for x? Well, I plugged in 3x squared minus 4, and that means that would be my g of x. So if I plug this into here, I would get that back out. And so these are how you decompose functions. You just have to kind of think, how did I get to there? What would I use as my original function, say f of x? What did I plug into that to get to the h of x? And that's how I did all 3 of those. All right, so now our last one is the last application problem. And here we have the radius r in inches of a spherical balloon is related to the volume V, capital V, by r of V equals, and now we have the cubed root of 3V over 4 pi. So that's what r of V is equal to. So r means radius. And so air is pumped into the balloon, so the volume after t seconds is given by V of t equals 10 plus 20 t. And we want to find the composite function r of v of t. So basically, we're taking the v of t, plugging it into here, which means that's going to be plugged into here for v, and we're going to get our composite function r of v of t. So r of v of t. All right, so we're, again, plugging this in place of v. So we have the cubed root of, now that's going to be 3 times 10 plus 20t over 4 pi. All right. Now, do we need to multiply that out? You could, and distribute it. But again, if you left it like this, that would give you kind of a more feel of how it originally relates to each function on each piece here. And so that's what I would say I would use for part A. Again, you could distribute, and if we did that, that would be the cubed root of 30 plus 60t over 4 pi. But we don't have to. We can leave it as that. Now, what does B say? Well, B says find the exact time when the radius reaches 10 inches. Well, radius is r, so that means this. And so what we're going to do is we're going to say, well, 10 is equal to, and now we have the cubed root of, now again, we could put it all together, we could take it apart, it really doesn't matter here, but that's going to be 3 times 10 plus 20t in parentheses over our 4 pi. Now, since it says exact time, we have to keep everything in terms of pi here, so we have to keep that pi. Now, how are we going to solve this? Because we need to solve basically for the time t. Well, we need to get rid of this cubed root first. Well, to do that, what we're going to do, let's go ahead and show that on this first line. We're going to cube both sides. Okay. Now, when we cube a cubed root, basically that drops, and on the right, we just get 3 times 10 plus 20t all over 4 pi. And on the right, 10 to the third means 10 times 10 times 10, which is going to be 1,000. Okay, now what do we do? Well, now again, we're on our way to solving for t. So if we multiply by, now let's get rid of that 3 over 4 pi. So if we multiply by 4 pi over 3, that would get rid of it because that 3 would cancel, the 4 pi's would cancel. And so then what we have, let's move up here so I have room. I'd have 4 pi times 1,000, so that would be 4,000 pi over 3 is equal to, then I have 10 plus 20t. Okay. All right, now what do we do? Well, now I'm going to subtract 10, and so I'll subtract 10 here. Now, if I put that all together, I need to go ahead and get a common denominator and things like that. Or if I wanted to leave it as itself, I could do that as well. It kind of depends on your mood. But anyway, that's going to be 4,000 pi over 3 minus 10 equals 20t. And again, I could combine that and say 4,000 pi minus 30 over 3, or I can leave it as the two fractions. It really doesn't matter. Now I need to get rid of that 20. So I'm going to divide by 20, but because I have a fraction here, I'm going to multiply by 1 over 20 instead. So that kind of makes it so I have something that's easy to do because it's the same thing as dividing, but when you divide here by 20, then you got a fraction divided by a number, and it makes it sometimes difficult for some people. So now I have 1 over 20 times 4,000 pi over 3 minus 10. Now I need to distribute on both of those. So 20 will go into 4,000 what? Well, it'll go in 200. So that's 200, and then have pi, that's all over 3 still. And then 10 divided by 20 is going to be minus 1/2. Okay, and that's equal to t. So basically my time is going to be equal to 200 pi over 3. Let's make it a little nicer looking. Over 3 minus the 1/2. Again, if we wanted to combine that all into one fraction, we could, but this is good enough for the question in hand. It wants the exact value, and that is an exact value with two fractions, of course, but it's okay. We can simplify and make that 400 pi minus 3 all over 6, and that would be another fraction we could use as well. All right, so that's all I have for section 1.4.